We're going to look at how to solve equations that contain logarithms, and we're going to use two very simple properties that you should already have a good understanding of if you've practiced with logarithms at all. So we'll begin with an equation that we need to solve, and we'll start with a very simple one. Log base 3 of 2x plus 1 equals 2. And so to solve this equation, since you have log equals a number, you can very simply rewrite this in its exponential form. In other words, here's your base, so 3 to the second power, 3 squared, equals the argument 2x plus 1. And now there's no logarithm here. This is an equivalent form of this equation. 3 squared is 9, equals 2x plus 1. Subtract 1, divide by 2, and we see that x equals 4. Now I didn't circle it yet because we have to make sure that we check this answer. The reason is, if you recall, with logarithms, the argument, this thing right here, whatever you take the log of, has to be a positive number. And you'll see that if you plug a number in and that it's negative, you'll try it in your calculator and you'll see that it doesn't work. So we need to plug x equals 4 back in to check this. And it's very easy to see that if you check it, you get log base 3 of 2 times 4 is 8, plus 1 is 9, equals 2. Well, log base 3 of 9 is 2 because 3 squared is 9. So this does check. So x equals 4 is the solution to this equation. Okay, here's a different type. You wouldn't want to use the exponential form. When you see natural log or ln, remember this is base e. So if you do e to this power equals this, you get something with this logarithm as an exponent. You can do that, but there's an easier way. Anytime you have a log equals a log, or natural log equals a natural log, as long as the bases are the same, ln of this guy equals ln of this guy. That means the two yellow guys, the two arguments, have to be equal to each other. If the log of this equals the log of that, then the two yellow guys have to equal each other. So we can say, by dropping the logs in this case, that 2x plus 5 has to be 3. And now we subtract 5, divide by 2, and x equals negative 1. Now we should go back and check this to make sure that we don't have any trouble. 2 times negative 1 is negative 2, plus 5 is 3. So this inside here is 3. So we have the ln of 3 equals the ln of 3. So it does work, and this is our solution. Okay, in this example we have logs everywhere. Everything's a log base 4, so in theory we could combine all the logs. So our goal is going to be to combine all of the logs, the two logs on the left side, together to get a single log. So it's going to look something like this. Log base 4 of something equals log base 4 of 18. And then since we have log of something equals log of something, we can simply drop the logs like we did in the previous example. The question is, what goes here? What do we take the log of here? Well, when you have addition between two logarithms, you can combine the two logs into one by multiplication. So you would take x times x minus 7. So you'd have x squared minus 7x when you combine the logarithms. These are just simple properties of logarithms we've already looked at. And now, since we have log base 4 of this argument equals log base 4 of this argument, the two arguments have to be equal, so we can just drop the logs. This is a quadratic equation, so we should get one side equal to 0 and try to factor the other side. And we can see that x equals negative 2 or 9. And remember, we have to check. Well, I can tell already that negative 2 is not going to work because I can't take log base 4 of a negative number. So negative 2 is out. 9, however, we need to look at. So we'd have log base 4 of 9 plus log base 4 of 9 minus 7, which is 2, equals log base 4 of 18. And we know that if we combine these two logs by multiplication, 9 times 2 is 18, so they are equal to each other. So 9 is actually a solution to this equation.